Welcome to 3.4, the chain rule. Our goal today is to find the first derivative of functions that are written as composite functions. What we're really looking for here are functions in functions. So a composite function is function m composed of functions f and g. Here we can see we have f of g of x. The domain of M is all real numbers x, such that x is in the domain of g of x and g of x in the domain of f. So, our general power rule is if u of x is a differentiable function, n being any real number, and y, which is our function f of x, is u of x raised to that power of n, we can use our power rule just like we have before where we bring the exponent down and subtract 1. But then, since we have a function on the inside, we have to take the derivative of that function on the inside. And that's our chain rule, is you take the derivative of the outside and then you take the derivative of the inside. Here we have the definition of our chain rule. If y is f of u and u is g of x, then our composite function would be f of g of x. So, in order to take the derivative of y, dy dx, we would take the derivative of y with respect to u, and then take the derivative of u with respect to x. So again, we're taking the derivative of the outside and then taking the derivative of the inside. Find m of x equals f of g of x if f of u equals u to the fourth and g of x equals 2x squared minus 8x plus 15. So, since m of x equals f of g of x, and we have g of x here, I'm going to plug g of x in, 2x squared minus 8x plus 15, and f is u to the fourth. So this is going to become 2x squared minus 8x plus 15 raised to the fourth. We just keep inserting each function, and that makes it the composite function. M of x equals f of g of x. F of u is natural log of u, and g of x is 4x squared plus 7x minus 35. So again, if m of x equals f of g of x, let's start by plugging in g of x, 4x squared plus 7x minus 35. And f tells us take the natural log of whatever's getting plugged in. Natural log of 4x squared plus 7x minus 35. So these are to practice seeing composite functions. Given y equals x to the fifth minus 7x squared plus 2x minus 21, all raised to the fifth power, write this composite function in the form of y equals f of u and u equals g of x. So what's happening in terms of y? Well, it's taking this inside and raising it to a fifth power. So that's what we're going to write. Y is u to the fifth. Now what's inside? That's going to be our g of x. And g of x is x to the fifth minus 7x squared plus 2x minus 21. And that's all it's asking us, is to break it up into what functions are making this composite function. Here we have y equals e to the negative 5x cubed plus 4x minus 23. So our y function is e to the u power. And our u, is negative 5x cubed plus 4x minus 23. Okay, so now that we've gotten some practice looking at and creating composite functions and breaking them apart, let's find derivatives of them. This is where our chain rule comes in. F of x equals 3x to the fourth minus 5x plus 13, all raised to the fifth power. So, in this case, we will take the derivative of the outside. That's using our power rule. So it's a fifth power, we're going to bring that down. So I have 5 times everything inside, 3x to the fourth minus 5x plus 13 to the fourth power, because we subtract 1 using our power rule. And now we use the chain rule, and we have to take the derivative of what's inside. So we'll multiply by the derivative of 3x to the fourth, 12x cubed. The derivative of 5x is 5. The derivative of 13 is 0. And that's it. We're gonna stop right there. Don't feel like you need to multiply this fourth out. Multiplying that out 4 times will be a long function. This is fine. Okay, let's do another one. So remember, we're taking the derivative of the outside and working our way in. So, our derivative. I'm going to pull the constant out front, and we have natural log of something. So the outside function is natural log. What's the derivative of natural log? 1 over x. So we have 1 over what we've plugged in, 12x plus 5. But we have to multiply it by what's inside of there, 12x plus 5. So the derivative of 12x plus 5 is 12. And if we do 7 times 12, we will have 48 over 12x plus 5. Oh, 48, I meant 84 over 12x plus 5. Oh boy. Okay. F of x equals 7e to the 2x minus 3. So, to find our derivative, we need to use our chain rule. We'll pull that constant out front. The derivative of the outside function is e to the u. And derivative of e to the u is itself, e to the 2x minus 3. Now the derivative of the inside, 2x minus 3, derivative of 2x is 2, the derivative of 3 is 0. And so our derivative will be 7 times 2 is 14, e to the 2x minus 3. Y equals 6 times x squared minus 3x plus 12 raised to the 6th power. Our derivative, we will pull that constant out front. The derivative of the outside is u to the 6th power, so we'll use power rule. 6 times whatever's plugged in minus 1, so to the 5th. And then we have to do the derivative of the inside. So the derivative of x squared minus 3x plus 12. Derivative of x squared is 2x. The derivative of 3x is 3. And the derivative of 12 is 0. So now we have 6 times 6 is 36 times 2x minus 3 times x squared minus 3x plus 12 to the 5th. F of x equals the cube root of 2x squared minus 3x. Let's start by rewriting this using exponents. The cube root can be rewritten as a power of 1/3. That way we can use our power rule. So our derivative will be the derivative of the outside, which is just the power rule, 1/3 times 2x squared minus 3x to the negative 2/3 times the derivative of the inside. Derivative of 2x squared is 4x. The derivative of 3x is 3. So we have 4x minus 3 over 3 times 2x squared minus 3x to the negative 2/3. Now let's put that 2x squared minus 3x in the denominator, so that way the 2/3 power becomes a positive exponent. So we have 4x minus 3 over 3 times 2x squared minus 3x to the 2/3 power. And the last thing I would do is rewrite the 2/3 power as a radical. That way we don't have a fraction exponent. So we have 4x minus 3 over 3 2/3. So we have a cube root of 2x squared minus 3x all squared. If you need to, please review your exponent properties to make these simplifications a lot easier. Y equals the natural log of 3x plus 7, all cubed. Okay, so it looks like we will start with a power rule because everything is being cubed. So y prime, our first derivative, the outermost derivative is going to be power rule. So 3 times the inside squared. And the inside is natural log 3x plus 7. Now the next one we see is the natural log of something. So we're actually going to do the chain rule of that part. The natural log of something, so we take the derivative of natural log, and it's 1 over that, whatever it is, 1 over that something. And that something just happens to be 3x plus 7. And then, since that was inside of the natural log, we have to take the derivative of that. So derivative of 3x plus 7 is 3. So this is why it's the chain rule, because it just chains on however many functions are inside of this composite function. is how many chains we're going to have. So in this case, we had to do it twice. Okay, let's make some simplifications here. Looks like 3 times 3, 9. Natural log of 3x plus 7 squared over 3x plus 7. Okay. And that is our last one for today.